So in this video, we are going to talk about one of the real-life problems of arithmetic sequences. So let's try to have a look at the background information. Josie pays money into a savings scheme each year, and it lasts for 50 years. In the first year, she pays $4,100, and it is also given that her payments increases by the same amount each year. In addition, it is given that she pays $4,350 in the second year. So, what can we do in order to determine which kind of sequence we can use or we can refer to? That is, for example, for this question, we can try to look at this one. It is given that the payments increases by the same amount each year, which means when we are going to look at the differences between the payments in consecutive years, they must be the same because of the same increment. That's why from this information, we can see that the payments should follow an arithmetic sequence. Once we confirm that this follows an arithmetic sequence, then we can try to consider the other information. We can see that in the first year, she pays $4,100. So this is the information for the first year. Then we can try to define the first term U1 would be 4,100. And from the last sentence, it is given that she pays $4,350 in the second year. So we can try to consider U2, the second term, would be $4,350. So in part A, we are going to find the amount that Josie will pay in the 15th year. Which means in part A, we are going to find the value of U15, which would be the 15th term of this arithmetic sequence. So from the background information, as we are given the values of the second term and the first term, that means we can try to use the formula D equals to U2 minus U1 to find the common difference of this arithmetic sequence. Then we can try to consider the second term 4,350 and the first term 4,100. We can try to consider the direct subtraction 4350 minus 4100, which would be 250. And as we know that in order to find the amount that Josie will pay in the 15th year, that means the 15th term, that means we have to consider the values of the first term and the corresponding common difference, as we are going to use the general term formula of the arithmetic sequence. Un equals to U1 plus the bracket n minus 1 times d, where Un represents the nth term as well as the general term, and also n means the ranking of the term. And the reason why we have to use this, that is, in part A, we are going to find the 15th term. That means we are going to find U15. Then we can try to consider applying this formula, and for your information, this formula will be available in the formula book as well. So, by using this formula, we can try to consider n to be 15. We can replace U1 by 4,100. We can replace D by 250, such that we have 4,100 plus the bracket 15 minus 1 times 250. Then, as a result, we have $7,600 to be the answer. And then in part B, we are going to find the exact total amount in over the 50 years, which means we are going to consider the total sum of these 50 amounts among those 50 years. And if we consider the word exact, that means we are going to present our answer in exact value. And also the word total means we are going to apply the sum of the first n terms formula instead of the general term formula. Then in order to find the total amount, we can try to consider this formula as n equals to n over 2 times the bracket 2u1 plus bracket n minus 1 times d. Sn means the sum of the first n terms, and the variables n, u1, and d are having the same meanings. Then we can try to consider replacing n by 50, replacing u1 by 4,100, replacing d by 250, such that we have 50 over 2 times the bracket 2 times 4,100 plus the bracket 50 minus 1 times 250. Then we will have this result, $511,250. And for some of the examples involving arithmetic sequences, if we are required to find the sum of the first n terms, and at the same time we are given the values of the first term and the nth term, then we can try to use this formula Sn equals to n over 2 times the bracket, the sum of u1 and un.